Here's a quick explanation of Newton's laws of linear motion. Okay, Newton has 3 laws that explain linear motion. Linear motion is movement in a straight or a curved line. And the 3 laws, it's important that you can number and name them. So the first law of inertia, the second law of acceleration, the third law of action-reaction. You don't want to be mixing those up. So you need to absolutely nail on that you've got those names. The second thing you need to be able to do is define them. Okay, and then the third thing, the important thing for your application scores, is to make sure you can apply that law or each of those laws to scenarios. So I've given you 3 on the board there. We've got a sprinter, we've got a gymnast on the beam, we've got a footballer jumping up for a header. All of these have appeared on exam papers. So if we just spend a minute looking at each one, and then you're going to have a go at applying them. So let me just zoom in here a second. So the first law, the law of inertia. This one says that a body continues in a state of rest of uniform velocity unless acted upon by an external unbalanced force. You remember when we first looked at inertia, we looked at a ball and we said the weight of the ball acting down from its centre of mass will be equal and opposite to the reaction force from the ground. And when we've got a balanced force like that, we're in a state of equilibrium or a state of inertia. And if we have a quick look at our sprinter there, you can just see her in the starting blocks. At that moment in time, she's in a state of rest. She's in a state of inertia. She's stationary. So we know if we needed to apply the first law to a sprinter, that body is going to remain stationary until she applies or an external force is acted on her. And we know to create an unbalanced force, she needs to apply a muscular force through the ground that's larger than her inertia to start with. So that's the first law, the law of inertia. If we have a little look at the second law of acceleration. Now this is interesting because with the second law, you'll usually get a mark for giving the little formula. So force equals mass times acceleration. And we know that in sport, the mass of a body, so if we look at the gymnast and we look at the sprinter there, their mass isn't going to change from the start of that race or event to the end of it. So their mass remains the same. So actually the only thing that's going to affect those performers' acceleration, either forwards for the sprinter or upwards acceleration for the gymnast, is going to be the force that they apply. So it says there, the acceleration of a body is directly proportional to the magnitude, the size of the force produced, and it's governed by the direction that the force is applied. Let's just have a little look at that. So there we go. If we have a look at the sprinter, she's going to need to apply to the ground or to the blocks a muscular force by contracting her gluteals and her quadriceps and so on and so forth. She's going to need to apply a muscular force to the ground that's bigger than her inertia to get her moving to start with. But if she wants to go as fast as possible, the greater the force she applies down generates a large reaction force upwards, causing her to accelerate. So really, if you're applying that second law of acceleration, you're going to be saying that the greater the muscular force applied to the ground or by the body to whatever it is, the faster, the greater the acceleration is going to be. And this is important, this bit about it being governed by the direction that the force is applied. The gymnast is going to apply a muscular force down to the beam, but the thing that's going to make her accelerate, the thing that's going to make her move, is that the beam is going to apply a reaction force back on the gymnast. And obviously, the more force she applies down, the more force acts up on her, so the faster she'll accelerate upwards, giving her the height to complete whatever move, whatever leap it is in the air. And then very quickly, if we have a look at the third law, the law of action-reaction, this one says for every action there is an equal and opposite reaction force. So for every action force there's an equal and opposite reaction force. We've kind of already covered it. So as the gymnast applies a muscular force down to the beam applies a reaction force up on the gymnast that's equal but opposite to that original force. So what I'd like you to do is just for a second, if I just make that all a bit smaller, there's 3 scenarios there. I want you to choose maybe 2 of them, because we need to get in the habit. And what you'll see is when we look at the answers in a minute, it's pretty much the same answer, just rejigged, remolded for the scenario. So there's 3 scenarios there. We've got a sprinter, we've got a gymnast performing a routine on the beam, and we have got a footballer jumping up to do a header. What I'd like you to do is apply each of those. Now you might just want to pause this for a second while you do that, because I'm now going to explain those to you. Okay, if I just move, can I move my sprinter? Hang on. Yeah, let me move my sprinter down here. Let's make this a little bit bigger. All right, so here we've got our sprinter, and where it says 1, 2, and then 3 across here, they're each of the laws that we're going to talk about. We've kind of covered all of these already with the sprinter, but let's just have a quick whiz through. So the sprinter is stationary in the blocks. To alter her state of inertia, because that's what she's in, she's stationary, she's in a state of inertia, she's going to apply a muscular force to the blocks by contracting her leg muscles. Tell me where that force comes from, and that force needs to be large enough to overcome her inertia, so it allows her to move, that initial movement out of the blocks. For the second law, because the mass of the sprinter remains constant, her acceleration out of the blocks is directly proportional to the muscular force that she applies when she contracts the muscles in her legs. The more force that she applies to those blocks, the more force from those muscles, the greater the acceleration, the faster the acceleration out of the blocks will be. And hopefully she'll get a better start than her opponents. And then the third law says the sprinter applies a muscular force to the blocks by contracting the leg muscles, and the blocks apply an equal and opposite force back on the sprinter. The more force she applies down and back gives her a greater upwards and forwards reaction force on the sprinter, giving her the momentum to move forwards and accelerate down that track. Okay, if we just have a little look at the gymnast, let me try and move her along. Here we go. So we've got a gymnast on the beam here. Make that a bit bigger. Look at the first law. So to start with, she's in a state of inertia. If she wants to move, she's going to have to apply a force down to the beam that's large enough to overcome her inertia, and that will start the jump. So the first law is all about starting the movement. The second law says because the mass of the gymnast remains the same, it remains constant during that routine, her acceleration, her upwards acceleration, is going to be proportional to the muscular force that she produces. The greater the muscular force she produces or pushes down onto the beam, the greater the upwards acceleration will be in her jump. She'll get higher, she'll be able to complete the necessary moves, she'll get the height to complete the moves. And then finally at takeoff, for the third law, the gymnast's leg muscles contract and push down onto the beam, and the beam then applies an equal or opposite force back up onto the gymnast. We already know that the greater the downward force applied to the beam, the larger the upwards force applied by the beam to the gymnast. And this gives her time to jump up into the air higher, gives her more time in the air to complete those aesthetically pleasing movements, which will score her more points. One of the things you do need to consider, in order to, she doesn't want to just go straight up, she wants to take off at a bit of an angle. So if she takes off at the correct angle, she's going to maximize a distance on the beam, the height at takeoff, and then obviously be able to complete her movements. If she's got the incorrect angle, it'll limit her height, her time in the air, and it could lead to point deductions. And then last but not least, if you have a little look at your footballer jumping up for the header, it's the same old story. The first law, they apply a force to the ground that's large enough to overcome their inertia, so they'll move from a stationary position to a jump. Second law, because the mass of the footballer remains constant, the greater the muscular force applied to the ground, the faster they'll accelerate upwards. So they apply a force down, they accelerate upwards in the direction of that force, of the reaction force. This means they'll get higher to meet the ball in the header. And the third law, for every action there's an equal and opposite reaction. They apply a muscular force to the ground or the pitch, and the pitch applies an equal and opposite force back onto the football player. If that force is a big force, if it's large, they're going to generate, so if they apply a large force down, they'll generate a large reaction force upwards from the ground onto them, allowing them to jump higher and be more likely to meet the ball at the optimal height for a successful header. So that concludes everything really that you need to know about Newton's laws and applying them. So go away now, have a look at the questions that are on the Padlet and start to practice some of those.